All right. Good morning, everybody. It's 10 o'clock here in Finland, so we're ready to start. Today's agenda for the webinar is Agentic Solutions in Databricks from development all the way to production. This is a practical session in the sense that we'll share real architectural patterns, customer story, and lessons learned. To get most out of this webinar, we hope you know the basics of GenAI and Databricks, but if you don't worry. In case you have questions, feel free to use the QA section of the platform, and we have a 10-minute slot at the end to answer them. All right, let's get started. Quick introductions from my side. I'm Olli Kave, and I'm the tech lead for Databricks here at Solita, Finland. Been working many years for building data platforms and AI solutions, both on consulting and on the client side. And to you, Prakati.
Yes, thank you, Olli. Hey, everybody. I am Pragati Gupta. I've been working in industry for 8 years now, with experience in startups, product giants, and consultancies. My expertise is primarily in machine learning, computer vision, natural language, MLOps. But now, thanks to the GenAI boom, I have been working full time on GenAI for 2 years now. Thank you, and so excited to have you all today with us.
Thanks, Prakati. A few words about Solita first. Solita is a European company founded 96 in Finland, Tampere. We have over 2,000 employees across 9 countries, and turnover last year was 270 million euros. Basically, our mission is to cover the full spectrum from strategy and design to data and AI, software development, cloud, and integrations. And Solita is one of the leading EMEA Databricks and AI partners. We are the gold level partner for Databricks and one of the few Databricks Lake-based launch partners. Our aim is to be one partner for our customers. And what we do with Databricks is we build and migrate data platform solutions. And also the AI side, we take AI solutions to production using MLOps, let them be AI agents, AI-enabled apps, etc. And here's some of our customers at the bottom. All right, for today's agenda, we have reserved 1.5 hours, but let's see how long we actually need. We have a Q&A section at the end. But we start from the GenAI shift, paint the picture a bit, then go through a customer story from a company called Lumio, then explain a bit why Databricks was the choice for Lumio's Agentic AI, and then do the actual brief, what data to choose, how to build and deploy the Agentic pipeline, then go over through the evaluation with CI/CD and governance, and finally end with the key takeaways and, as said, the Q&A. All right, as you all know, the GenAI shift is going strong, and according to a recent report, already 85%, might be even more today, are using GenAI in some capacity of the global enterprises. The industry focus has shifted firmly towards production readiness. So POCs are not the focus anymore. Now the shift is trying to get those POCs into production. But the same study also showed that 95% of those POCs don't reach production because challenges in quality, governance, and cost. And the gap between the demo ready and production ready is now the biggest bottleneck in the AI adoption. Here are the major blockers that we see across organizations when we talk to our clients. First is the governance. Basically, there's no clear ownership of the model's prompts and outputs. It's also difficult to enforce access controls and audit trails, and also hard to meet compliance and regulatory requirements at scale. The second point is quality of the actual solutions. Many times the outputs are non-deterministic and prone to hallucinations. There's no standards for evaluation, and it's difficult to guarantee consistent, reliable results in production. And as we all know, the technology is moving fast, some would say even too fast. It's hard to commit to a long-term architectural decision and thus risk the technical debt that accumulates with the decision if it's a wrong one. All right, now to the customer story and to you, Pragati.
Yes, thank you, Ali. So for this demo, for especially this webinar, we have built a hypothetical use case inspired by real Solita customer projects. We have narrowed the scope in few ways. For example, we are kind of assuming that an infrastructure team is already in place. The infra team has already set up Databricks. The company has completed AI compliance and ethics review study. Security has approved moving forward with the AI application development. So we are assuming that everything I mentioned is in place. Yes, now meet Antonio. Antonio is a customer service representative based in Mexico. He handles customer questions all the time. The customer questions may arrive in email, text, phone calls. He wakes up at 8 a.m. in the morning and he just realized that he has 38 emails already waiting for him. Every answer requires opening at least 3 systems. For instance, delivery status is an ERP database. Product specifications and certifications are scattered across thousands of PDF documents. Previous configurations for this client is buried in email threads. Then we have a lot of use cases, customer stories in SharePoints. The documentation is English. The customers expect answers in Spanish. Antonio might even need to contact somebody from another department in order to answer these questions. There was this lady, Paula, who used to handle this, but she left the company and now the knowledge is lost. Antonio is like, I have to find a way to solve this fast. By the time the answer is ready, 5 more questions have arrived. And this is how Antonio feels every day. Is it a Lumio problem? Definitely not. I'm sure your company must be having some teams who are doing the exact same manual work over and over again. Just another thing from me. I don't want to be a tech influencer here and try to influence you for start using agents. My goal is to bridge the gap when you need agents, when you don't need agents, and if you do need agents, what is the best way to go into productions? So Lumio's knowledge exists, it's just scattered. Every person on that team carries years of expertise, but no single person and no single system holds it all. The gap between what a company knows and what any person can access in real time is not unique in Lumio. And it is definitely a big bottleneck of enterprise AI adoption today. So, what Lumio needed? They didn't need a chatbot, they didn't need another dashboard. they needed an agent that could query live order data, search thousands of technical documents instantly, understand context from previous client interactions, make use cases from the previous use cases, could talk in multiple language, and do it reliably in production every single day. So, this is a story of how we made Antonio 10 times more effective. I don't know if you noticed the slides before, but Antonio was bald. But now, thanks to our agent, Antonio's stressless life has brought his hair back. Over to you, Ali. Would you like to tell us a bit about Databricks?
Thanks, Prakati. Previously, we mentioned blockers that prevent taking solutions to production, and here are some of the reasons why Lumio chose Databricks to address those issues. First of all, Databricks provides an end-to-end AI lifecycle from building and deploying to monitoring those enterprise-ready GenAI applications. Second point is the data integration and the data lakehouse capabilities that Databricks has. Basically, you can securely leverage your own data to fine-tune open source models or in RAG solutions. AI Gateway is Databricks' solution to offer guardrails, rate limiting, and act as a unified API for all the foundation models. Then the Agentic framework simplifies the development. For example, if you need to use multiple models, you can build chains with this framework. And then finally, the integrated governance built on top of Unity Catalog to ensure privacy lineage and compliance across the workflow. Here is a big picture of the GenAI capabilities of Databricks, organized into 3 different pillars. In the left is where you actually build your solutions using Agentbricks or Mosaic AI. There are the RAGs and agents, vector searches, custom models, then the MLOps or LLM-ops for the actual operationalizing everything. And then we have the agentic evaluation and then model serving and auto ML to actually handle the deployment side. Then the second point in any GenAI model means that you're not locked into any proprietary models. You can use open source models like MetaLlama or Databricks' own DBRX, or then the commercial ones like OpenAI Claude and Google Gemini. Then unified governance is handled by the Unity Catalog, offering end-to-end lineage, access controls, PI detection and guardrails, and a lot of features for the logging and monitoring. The key message is here that it's a one integrated platform. You don't need to glue in separate tools for building, deploying, serving, and governing your AI workflows. Here is a bit of a recap of the different AI solutions. Prakati will tell you more about this in a bit, but just to go through them from left to right, to less compute intensive to more compute intensive on the right side. So basically prompt engineering means crafting a specialized prompt to guide the LLM behavior. Then we have the RAGs, basically enriching the LLM responses with your own data. Agentic solutions, which are autonomous systems that use tools and reasoning to complete complex tasks. And then to the more intensive tasks like fine-tuning a pre-trained model with your own data, or even training a foundation model from the scratch if you have the muscle to do it. But basically, Databricks covers this entire spectrum. You can start simple and scale up as needed. Some other features to mention, usage tracking and observability, basically monitor who is using the models, how often, to help optimize performance and manage costs. Payload logging, you can capture requests and responses in Unity Catalog for debugging and improving the model quality. Unified guardrails offer a single source of truth for data policies with guardrails like PII detection. Then you can do A/B testing with different model versions and set traffic policies for different models. You can use Unity Catalog for permissions and AI Gate for rate limiting. And then we have the GenAI evaluation stack, for example, with MLflow experiments and tracking, LLM-as-a-judge, custom scorers, or human in the loops. Pragati will mention many of those in the coming slides. All right, to you, Pragati.
Thank you so much, Ali. So for the purpose of this webinar, we are sort of making an assumption that you know the basic terminology of generative AI applications, because this webinar is about taking them to production. So just a assumption. However, we will briefly cover some topics for people who are not familiar. So first, when it comes to the whole concept of Gen AI, we all know prompting. So the idea is you ask a question, you get a very fancy answer. The backbone is a model that has been trained on massive data set. And now you're using this model for inference purposes. So you can, like, if you are a developer, you can think of it more like an HTTP request response. Your ChatGPT, your Perplexity, they are examples of prompting. Then came the era of RAG, Retrieval Augmented Generation. Two important things to notice here: retrieve plus augment. Some people also refer to this RAG concept as grounding, because you are grounding your knowledge to your context. So let's talk about the two keywords I mentioned. First, retrieve. So what happens behind the scenes is you give a prompt. Based on your prompt, the data is retrieved that has the same context. So how it is retrieved? Again, think of it like a fancy semantic search. So your data is retrieved based on your prompt. Now comes the second keyword, augment. What does it mean? It means that you augment your prompt with the retrieved results you have received from your similarity search or some other algorithm. Once you augment, then you pass these results to LLM. LLM then gives you an answer. So it is called grounding because you grounded the LLM to the context. In doing so, you prevented the hallucinations that happened in case one, which is prompting. So your GenAI application has more knowledge of your data instead of the generalized data large language models has been trained on. Then came the era of agentic solutions. User asks a question. The LLM reasons what to do in order to get an answer. So what is the reasoning? Think of it like a brain. The LLM decides what to do. The LLM decides what actions it needs to take in order to come to an answer. What's different here is that you provide tools for the agent. A tool could be a Python function, it could be a vector search, it could be an API call, it could be an SQL query, it could be anything. Like any program you use in your everyday life, that could be a tool. The agent then observes the answer after calling the tool. If the agent is not happy, the agent can call another tool. And this process happens in loop till the agent is not satisfied satisfied with the answer. And that's how agentic framework works. On top of agentic framework, then people started experimenting with agent to agent. What if I make the agent start collaborating and communicating with each other? And the possibilities are just um, it's just, yeah, you can now, there are so many things. You have one orchestrator that has multiple agents talking, and then the agents respond to the orchestrator, or you have agent to agent, that agents are just talking to each other. There are so many possibilities out there. Ollie, if we have some questions in the chat, would it be okay for you to tell me the questions, and if I feel I can answer them right now?
Yes, there's one question. Philip is asking, can it ask two different tools and then get the best answer from those tools? Or is it always only one tool?
It's usually one tool at a time. If the agent feels the answer from the previous tool is not okay, or the agent needs more context, then it calls the other tool. But yes, it's you can have multiple tools in the loop. Okay, so this is one of my favorite slides in this whole webinar, because most of the people are like, when Lumio came to me, they were like, oh, we need to build an agentic system. And I'm like, are you sure that you need an agent, or normal GenAI solution is applicable to them? It's just nowadays people just want agentic solution because it's a cool term, but most often they don't need an agent. So this is very important for you to distinct when you need an agent. You need an agent when the task require reasoning, tool usage, adopting based on intermediate results. Human in the loop is one intermediate result, that you ask a question, agent responds with the tool usage, but it's still not sure. It redirects the control to the human, and then human can help the agent in coming up with the final answer. Or the workflow which you're trying to solve has branching logic that cannot be hard coded upfront. That's when you need an agent. You do not need an agent when the task is predictable. It's linear, it's well defined. For example, you are trying to solve a workflow. You know that these are the steps you need to take. Step number 1, step number 2, step number 3. There's no thinking involved. You are just calling tools or sections one by one. That's when you don't need an agent. A normal GenAI application will help you solve your business problem. Or it's a simple LLM call, a deterministic pipeline that gets the job done. You don't need an agent for that. You cannot tolerate non-deterministic behavior, or you do not have guardrails in the place. That's when you don't need an agent. So every time you try to solve a use case you have within a company, ask yourself first, is it an agent problem or it's a generative AI problem? So we're going to just cover a bit about agentic components. We have covered that already in the previous slides, but we have 4 components that makes agent. We have a reasoning model, that is the brain. The choice of the model impact the cost, latency, and output quality. So you need to decide what type of model you want to use in your application. There are some models that are really good for, let's say, SQL queries, but there are some models that are really good for talking with humans. So you need to see what type of model is the best for your use case. Then the model must be swappable. Avoid tight coupling to a single provider. That's what agent is, that it's not really tied to a model. Just plug and play. You can use any model you want and then see the performance of the model later. Then the second part is the tools, which I have explained already, that it's an external function the agent calls. It could be APIs, it could be database, it could be code execution. It enables the agent to take actions beyond text generations. It requires strict input, validation, and error handling for production reliability. The third component is memory. Um, what is a memory? It allows the agent to retain context across interaction and sessions. The memory could be short term. For example, when you open a chat interface, you say, "My name is Pragati." Then you ask a question, "Do you remember my name?" The chat GPT says, "Yes, you are Pragati." But back in the days, the memory was only restricted to the session. If you open a new thread, you ask, "What is my name?" the 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 the, the interface won't remember because your memory is restricted to the session only. Then there is a concept of long-term persistence. That means the memory is retained across sessions. It could be across users as well. So that is also some business decisions you need to take within the company. For example, I ask a question, a business critical question, and then the agent comes up with that answer in 10 tool calls. Now, if Ollie makes that question, should he just replicate the procedure? That is a concept of long term memory, that instead of having the same thinking again and again, you just look into the database and see what Ollie did and replicate the same step. That is a concept of long term persistence. It is critical for multi step workflows and personalized experiences. Then we have a fancy term, MCP. It's called Model Context Protocol. It's nothing fancy. It's just a standardized way to connect models to external data. Think of it like a USB drive to an agent. You're just plugging external data sources. It reduces custom integration effort, plug and play operability, and it enables governed, consistent context delivery across agents at scale. And the best part is, if you are creating multiple agents and you can plug your MCP into multiple agents at the same time. So it's very scalable. So now we talked a lot about the components of what agent is, but what makes an agentic pipeline? What are the steps you need to take into account when you're building an agent system? Databricks broadly put them into 5 categories. It starts with data preparation, that the data is organized and pre-processed for the agent to use. Then comes the stage of agent development, which is selecting your GenAI models, creating your tools, or just dividing your problem into tasks. Then we have agent evaluation. Of course, we do not want our agent to be into production without evaluation. So end-to-end evaluation, how the agent is outputting the response, that everything about evaluation fall into the third component. Then once we are happy with the evaluation, once we are happy with how the agent is responding, and once we are happy with the performance of it, we deploy the agents. And so these are the 4 components about agent creation. And then comes the 5th component, that is governing everything. All the 4 components we talk about, we have another component that is governing everything. What governing means is that you are ensuring that the agents are packed for performance, for secure and efficient use by other users and systems. Another slide I have, it's not really related to the previous one, but it's just trying to solve, demystifying some myths here. Uh, some customers came to me that, "Oh, we want to use Databricks, but we have invested so much already into other agents. We have developers working on Azure, we have developers working on AWS or pure Python. So we do not want to reinvent the wheel in Databricks." So this slide is for people to know that you do not have to create your agents again in Databricks. You can just wrap them into a Databricks wrapper. The wrapper is called Response Agent. And once you wrap your agents around this, it becomes compatible with Databricks. That means all the services within Databricks can be used on top of these wrappers. It is ML flow for tracing, governance, or it could be Unity catalog, or it could be accessing any tool Databricks provides you. With this, you can wrap any existing agent. It could be LangGraph, DSPY, to get out of the box compatibility with Databricks. Databricks lets you build agents with any third-party framework and integrate them with Agentbricks. Then a bit of advertisement from my side. I have written a blog on how you can convert your LangGraph agents to Databricks. If you have time, or if you have if you have your LangGraph agents and you want to put them into Databricks, that blog might be helpful. Okay, now we have done the revision. We know the basic terminology of agents. We discussed the 4 components. We discussed the pipeline. Now we have data. Why this is important? What you get, what you feed into the agent is data, and why this is so important. Why are we talking about this? Everybody knows this concept of garbage in, garbage out. A small model with perfect data parsing usually outperforms a larger model with poor parsing. With GenAI, the model is often a commodity. The differentiator, which makes your agent outperform, is the data. In this webinar, we're talking about production-ready agents. So we need to talk about production-ready data. Data strategy must take precedence over model selection. When we talk about building or solving a use case in the company, having clean data is must. That should be a first step to think about that. Is this data ready for the agent to consume? So the first step in high quality agent pipeline is document intelligence. This is the process of converting visual documents into semantic format that LLM can understand. We are going back to our use case Lumio. We have Antonio again, based in Mexico. He just realized that there's so much data. Live order data is in ERP databases, product specifications and certifications spread across documents in PDF format. You have client history, email threads. The challenge wasn't just connecting these data sources. It was also to keep them updated. So you do not want to have an agent that is feeding on the old data. How to keep them updated? How to keep them live? So if the agent doesn't know that the data has been updated, it gives an old answer, and you as an end user doesn't know if the answer is old or new. So how in Lumio's case we solve this? We're going to talk a bit about how you can build data pipelines, how you can keep the data updated in this chapter. So we have built automated SDP. SDP is Spark Declarative Pipelines. For people who have been working on Databricks, it was called DLT before, Delta Life Table Pipelines. So it's the same concept. Databricks has been changing a lot of the services names. They're using, I don't know what's the reason, but yeah, they have been renaming a lot of services. So yeah, SDP or Delta Life Table Pipelines. I might be using this term interchangeably. So yeah, it's the same thing. So we build SDP pipelines that detect every change and update our vector search index in real time. The agent always works from the latest version of Lumio's knowledge. So this is how we solve this problem of keeping the data updated. I'm gonna show you in detail in the upcoming slides how this works. Basically, but what our strategy was. First, we discussed in our internal team that what is the data that needs to be accessible to this agent? What are the types of data that actually exist? There are many technologies out there to make the data accessible to agents. For example, if you want the agent to have a semantic search, you want to retrieve the document that have the same concept, people usually use the concept of vector search. Now there are so many other algorithms out there that you do not need vectors, page index. other algorithms out there, but vector search has been proven stable and quite efficient so far. So you have vector search for your semantic context retrieval. If you are interested in finding the relationships between your data, you might be interested in investing into knowledge graphs. If you have a requirement of analytics, that you might be interested in SQL queries, that the agent makes SQL queries. If you want live data, then you might be interested in API calls. So this is something you also need to realize, what is the type of data you want to use within our agent. For Lumio's use case, we realized we need semantic search for PDF documents. We need analytics, SQL search for ERP databases that are scattered across SAP, Snowflake, and then we need live data for making API calls to get some information about the internal systems. So we needed first, third, and fourth. For the first, which is semantic search, and how it's done in our Lumio's use case, we used vector search. There's a lot of confusion around vector search, so I'm just going to try to simplify it a bit. What exactly is a vector search? It's just imagine that you have a document. Let's say it's a 100-page PDF documents. You extract the text out of the PDF documents. Once you have the extracted text, you chunk the document. The chunking could be page by page. It could be section by section. It could be a topic by topic. So this is something, it's a chunking strategy. You need to decide in your organization what is the best chunking strategy. The output may vary a lot based on your chunking strategy. So now you chunk the document. You chunk by chunk, you embed them. What does embedding means? It's like, let's say in English text, I say, this is a mobile phone. Machines don't need English. Machines just convert this is a mobile phone. They convert this into an n-dimensional vector. The same for is a mobile phone. That is embedding, converting human language into computer understandable language. So you embed those documents. And once you embed these documents, you have vectors based on chunks. And now when a user asks a question, mobile phone or any other thing, your algorithm makes this sort of a similarity search. It first converts the query into embedding, and then it sees which embedded chunk has the maximum similarity. It gets the maximum documents, add those chunks into your prompt, and then it gives you an answer. That's how vector search works. Earlier, we have a couple of questions. I think I'm going to answer them right now. What is the best? Let me know if I missed any question. I see a question here. How was the quality of parsing 6,000 PDF documents tested? Yes, the quality was really good. So what we did, we extracted the text, and we used this concept called, it's a Databricks service. It's called AI Parse Document. It's a service provided by Databricks that helps you parse the document, at the same time makes a relationship with the images, with the table. So at the end, the vectors we created were quite good. And Lumio's managers have been quite happy with the PDFs. Then we have, what are the different chunking strategy? Is one size fits all? No, there's no free lunch algorithm. There is no chunking strategy that will fit all. You need to, and that is something chunking for me has always been sort of a hyperparameter that I set, and then I test it on the evaluation stage. So we used a lot of chunking strategy. There are a lot of chunking strategies out there. For example, you have one chunk, then you have The second chunk is not a distinct chunk. The second chunk has some overlapping context. So your chunks are overlapping. Then there is another chunking strategy that the next chunk is usually having the summary of the previous chunk. There are a lot of chunking strategies out there. So you need to test and see what works the best for you. Yes, the slides will be shared in the PDF format after this session. I think we can go.
Yeah, we have a lot of good questions in the QA section, but I think it's better to look at them at the end.
Okay, yeah. If you could get those questions for me, Ollie, we can discuss them later.
Yeah.
Okay, so now we are talking about healthy data for your agents. How you can create this data. If you are a person who has worked on Databricks, you know about Medallion architecture. This has been their the blockbuster term they have been using, a medallion architecture. What is a medallion? You process your data in 3 stages. You have bronze, that is just a raw ingestion of the data. Then you have a silver table on top of the bronze table, which is a filtered, clean, and augmented data. Then you have gold table, which is business level aggregation. This has been an architecture data engineers have been using. This has been an architecture machine learning people have been using. Why not to use the same architecture for GenAI applications as well? So Lakehouse, a Medallion, what I'm showing here is a Lakehouse design pattern organizing data into 3 layers for progressive data quality refinement. And for GenAI applications as well, you can use the same architecture. Let's see how we used this Medallion architecture in our use case. So we used SDP or DLT pipelines to create these 3 layers on top of each other. What are SDPs? They are declarative incremental pipelines. You have an autoloader that tracks which files are new and only change data flows through. Checkpointing means failure resume mid pipeline. The processes are not started from scratch. You have changed data feeds that keep the vector index in sync with full reindexing. You have Unity catalog lineage. You track everything, who does it, what happened, when it happened. So every vector traces back to its source file. Databricks recently launched this concept of Lakeflow Connect, with which you can build your SDP pipelines just with prompt. It has Genie integrated. You do not need to be a data engineer to build these pipelines. Just make a prompt and the pipelines will be ready. So how we incorporated Medallion with SDP? So we used SDP to create our Medallion architecture. And what it means in GenAI application, the bronze table means we are just ingesting raw data files and metadata as it is. For silver, we are extracting, we are cleaning, and we are creating chunks. We discussed about the chunks in the vector search. So we are creating those chunks in the silver table. And then we have a gold table on top of that, which is creating vectors on top of these chunks. So this is how we used Medallion architecture in our Lumio's use case. And because the SDP pipelines are triggered automatically, this is how we made sure our data is always updated. The agent has access to always updated information. Here's a screenshot of how SDP pipelines looked like in our Lumio use case. I hope the image is clear, but if it's not, I can just tell you that we have data getting ingested into bronze, then we have silver, we have gold. I request you to remember this Medallion architecture, the screenshot I have attached here, because we're going to use that later in LLM-ops. So just a revision, we need to clean our data. That's the first requirement, and the data needs to be updated. So that's why we build these pipelines to keep our data updated. Now we are done with the data chapter. Now we are focusing on, okay, I have a data. now I'm ready to build our agents. What to do? What are the steps I need to follow? Just a bit remark from my side. I'm not going to go very much into detail into building. There are so many YouTube videos out there. There's a lot of documentation from Databricks on how to build efficient agents. So it's just going to be a quick summary of how to build and some tricks and tips from my side. So Databricks provides a lot of services for building agents, and the steps I'm showing in this has been the steps that has worked for me for the clients I have handled. Every time a client comes up with a use case, first I do quick prototyping. I'm a believer of I need to fail fast, so I just quickly ideate on the AI playground. I experiment with the models. I just create fast tools and I just have a prototype. Once I'm satisfied with the prototype, I build my own agent in Python using any framework. LangChain has been my personal favorite, but you can use DSPy, you can use any other framework, native Python or OpenAI SDK. Feel free to use whatever. You define your own tools. You define, do you need short-term memory? Do you need long-term memory? What are the reasoning blocks you want to use? You can also decide what is the perfect model you want to use in this use case you're solving. Once you are satisfied with the development, next comes the part of optimizing. You can optimize your prompts. You can fine tune your prompts. You can work a lot on the evaluation part. Databricks has a lot of services to optimize your agent. Once you're happy with the optimization, then we connect and observe. We connect vector search or MCP to our and then once we are sure that the data is securely connected, you can use ML flow tracing in order to see how your tools are used. We're going to cover that part a bit in detail later, how the tracing works, how can you actually see what's happening inside the agent. So you connect and observe how the agent is performing, how the agent is calling the tools. Once you're happy, then you just send it to deployment. It could be model serving endpoint, it could be Databricks apps. So this is the 5-step procedure I have followed in building agents. One thing that makes me love Databricks is their native compatibility with MLflow. Well, MLflow has been created by Databricks and remains tightly integrated. Even though it's open source, you can use MLflow on your own system. But just the idea that everything I do on Databricks is just connected to MLflow automatically saves a lot of time and gives me a lot of flexibility on how I develop my agents. Bottom line is you use MLflow 3 for end-to-end lifecycle support, especially if you want to build the solution production ready. So yeah, we know that it's open source. MLflow 3 is the latest major release that supports building GenAI applications. You have the integration of for language models, you have prompt tracking, you have LLM-as-a-judge evaluation. Everything you do with the agent is tracked, traced, whatever you ask, how the agent responds, everything is traced. You have prompt engineering tools. This is something we have been using extensively with Lumio, that with MLflow, you kind of separate your prompts from your code in a way that, for example, the business person I was talking to, he was like, yeah, I have a lot of information on the business context, but I don't want to touch the code. What should we do? So we used this concept of MLflow registry, and I gave him access to that. My agent was just pulling the prompts from that registry. And the best part is the prompts were versioned. I could, if I'm not really liking the prompt, I could always switch back to the previous version. So everything, I could see who made the change in the prompts, how the prompts are handled. So just imagine it as a Git for your prompts. And MLflow gives you gateway improvements. It's a unified interface for multiple LLM providers with fallback routing. So if you're building your agents, I highly recommend MLflow. So what we built for Lumio, because we are in the build section, so I'm just going to tell you after using all the Databricks services, what we ended up building. So after months of building, we could query live order data in real time. We could search thousands of documents semantically. The agent could remember context from previous client interactions. The agent could talk in multiple languages. The agent could build new customer use cases from the old ones. And it's not just a chatbot, it is a reasoning system. It helps you understand how it came with the answer it gave you. Just another tip from my side, which is something I have been using a lot to build agent faster. It is recently released by Databricks. It's called AI, the agent skills for AI coding assistant. So you basically, for example, you're using Cloud Code or Copilot CLI for your application building. You just download the skills. The agent which you are using for local development knows how Databricks works and what are the services it can use. So it really make your development faster. And I have attached a link. Feel free to install the package in your project and let me know how it goes. Is your development faster after you use those skills? Okay, so we have covered the data chapter of agents. We have covered the build part. Now we're going to move towards performance and evaluation. Because this webinar again is about production, so we're going to focus more from the performance, LLM-ops, governance. And now let's talk about the performance and evaluation. Most systems start as POCs, where feasibility takes priority over scalability and governance. Access controls and auditing take a backseat to performance. It's usually the case until the issue emerges in production. There's another thing I have observed in the use cases I have solved is elevated permissions and accesses. Developers get broad permissions across all environment instead of role-based access controls. And then another issue of no audit trails. Teams can't track, they can't see what data agents accessed or where the agents failed. So basically, no debugging concept of agents. What happens? The result is 3 times longer deployment cycles, increased security risk, increased governance violations that could have been prevented with proper practices from day one. And this is something we did with Lumio. When Lumio came to us, we were like, right from day one, we're going to build a solution that we're going to take it to production. So everything we were doing, we were like, okay, sometime in future, we need to take it to production. So let's make our code according to that. So have healthy practices and think you're going to take into production. It's not just about having an answer. It's the agent will always answer you in some way and it always looks right. So your goal should be have a production ready system or just think about the production from day one. So how did we start evaluating our Lumio and how we knew that it was working? So I had a long discussion with the service designer working with Lumio, and then she was like, okay, let's make a matrix of what's happening. She was like, let's start with 2 rows, 3 columns. Let's start with what is an answerable question. You know that it's an answerable question and the agent gives you a correct answer. What exactly is that? Like, it's an ideal behavior. What we want is something we are getting out of it. And the matrix, and then she was like, how can you quantify, how can you evaluate this ideal behavior? Then we came up with a matrix. The matrix are correctness, precision, retrieval groundness, and retrieval relevance. Then we have undesired. If the question is answerable, the agent provides wrong answerable. We have undesired behavior, misinformation. And the metrics are correctness, precision, follows instruction, retrieval, groundedness. The same for if the agent says, I don't know, it's underconfident. The metrics are false, I don't know rate, relevance. Then you have an unanswerable question, but the agent gives a correct answer. It is just a lucky guess. And what are the metrics to solve it? So we created a lot of metrics in order to cater to these occasions. And what Databricks services we used? We used Databricks traces. It is MLflow traces, which provides observability required for complex agentic systems. The tracing captures detailed execution, information, logging inputs, outputs, metadata associated with each intermediate step or span of the request. It analyzes execution paths, inspects span details, and use interactive interface for visualizations. This is how the traces looks like. You have a question, you have an answer, and then you see how your response is generated based on the evaluations you have created. These are the metrics I created, and then I'm evaluating how my answer is. On top of that, we use LLM as a judge. What is an LLM as a judge? It is using LLM to evaluate evaluate your answer. So it provides valuation criteria for your model, agent, and application. LLM judges are a type of MLflow scorers that use large language model for quality assessment. You can use, Databricks has a lot of built-in judges. You have custom judges, you have code-based scorers, and third-party scorers. Okay, we are done with the evaluation. I hope I tried to cover some parts. Let's try to CI/CD or LLM-ops. Products change, certifications update, new clients arrive. Lumio needed a system that could improve continuously without redeploying from scratch every time. Every change, new documents, updated prompts, business rules flow through the same automated pipeline. So how it looks like in system. We used Databricks Job, which is a workflow orchestration and scheduling service within Databricks. So everything that the agent was doing end to end, we put that in a job. Each step contains multiple tasks inside it. The way of working is continuous integration and continuous deployment. It ensures that the latest code prompts and safety rules are deployed continuously. These individual tasks you see, they itself could be complicated tasks within. For example, the second part, which is ingesting, chunking, and embedding, is the SDP pipeline I mentioned before. So this is how we maintained our code end to end. What's a business impact? Change is captured and deployed easily. Quick rollouts, quick bug detection and fixing. Okay, so now you have continuous integration. What about the continuous deployment? How everybody knows about dev, QA, and production, how things work. This is something we worked on. This is something we worked with Lumio, that you have a developer who is using VS Code, and the developer has access to repository. It could be GitHub, it could be Azure DevOps, it could be Bitbucket. For our use case, it was Azure DevOps. Every time the developer make change to dev, the pipelines are run. How the pipelines are defined? They are Azure pipelines. You have a pipeline for dev, you have a pipeline for QA, you have a pipeline for production. You install the dependency, you run the test, you validate the bundle, you deploy to Databricks. For example, now I made a commit to dev. The whole job, which I showed in the previous slide, is run on the dev workspace. Now, the developer tested the dev, and he or she is like, okay, I like it. I want to move it to QA. You can run another pipeline for QA. It could be, merging it with main. It could be something else. The same thing for production. It could be having a production branch, but for our use cases, we were using a release feature on top of the main branch. And that's how the systems are continuously deployed. And what is deployed on these workspaces is the job I mentioned in the previous steps. It's a very complicated job, but everything is encapsulated into one job. This is how we solve the problem of continuous integration and continuous delivery. Okay, let's talk about elephant in the room. It is a big topic, a very heavy one. So why I want to talk about this topic is when Lumio came to me, they were like, can you please handle the governance side of the things? In my head, I'm like, I'm a developer. I'm not supposed to work on the governance. Like what is something you're talking about? Why it should be me who's working on the governance? So this is my learning from a lot of GenAI cases I have handled, and what you at your position can handle the governance. It's not a one person job. It takes a community to handle the governance. So why it matters: it protects users, sensitive data, critical business operation, ensure regulatory and ethical compliance, build trust. What it means for security: the agent makes predictable answers and stay within the limits, no harm, control access, keep humans oversight in place. Databricks created this five. Okay, somehow. Okay, yeah, my block. The interface was blocked for me. Okay, now it's working again. Databricks created this 5-pillar framework on how companies should handle the governance. You have 5 pillars. First is the AI organization. This pillar makes AI governance as a part of your overall company strategy. It focuses on clear business goals and managing people, processes, technology, and data properly. You have the second pillar, which is legal and regulatory compliance. This pillar helps organization follow relevant laws and regulations. It guides you on managing legal risk, undertaking industry-specific rules, and adjusting to new regulations. Then you have the third pillar, ethics, transparency, and interpretability. This pillar builds you trustworthy and responsible AI. It emphasizes on fairness, accountability, human oversight, and clear explanation of how AI works. Then you have AI ops, data, and infrastructure. This pillar covers the technical foundation for deploying and maintaining AI. Then you have the last one, which is AI security, and we're going to talk about it in detail because this is the pillar I handled. This pillar is for managing security risks throughout your AI lifecycle. It covers data protection, model management, secure deployment, cybersecurity measures to protect AI system. Now, a lot of things to unpack. We don't have time to cover everything because it's such a broad concept. So I created a cheat sheet for people who are in this webinar. This cheat sheet is: ask yourself who you are. Are you at a C-suite? Are you on the legal team? Are you in the ethics board? Are you a data engineer? Are you a person who is handling the infrastructure, or are you a developer? So based on your profile in the company, you need to take in charge of your pillar. For example, I am a developer. I took in charge of the 5th pillar, which is AI security, which mitigates security risk across the AI lifecycle. Like I said before, when it comes to governance, it's not a one-person job. It's a team effort. So collaborate within your company and take the pillar you are supposed to take. The slides will be provided. Just look at this cheat sheet. It might come handy. Like I told you, this is the pillar 5 was a pillar I worked on because I'm a developer. So what I used for pillar 5 is Databricks AI Security Framework, which is DASF, the acronym they created. It is you divide your end-to-end AI lifecycle into 12 components, and it is about what are the steps developers could take to make these 12 components more governed. Databricks created this Google Sheet. A link is provided here. The sheet has 12 components and questions. Did you do this? Did you do this? So as a developer, if you want to implement this DSF framework, just keep your Google Sheet open every time you are working on a component and see how you are developing. Evaluate your own development. I'm not going to go into detail because we don't have time, but there are some videos you can go into detail. We talked about how the governance should be taken into account, but I'm going to talk a bit about what are the services you can use for AI governance within Databricks. You have Unity Catalog, which provides a centralized control. You have Databricks provided authentication that gives the agent accesses what the agent should have. You have model serving endpoint, which provide a unified access. It is a sort of a service for managing all type of AI models, custom models, hosted models, external models. You have AI gateway. If just imagine if model serving is the pipe, AI gateway is a filter. This is something we used in our project for A/B testing, for user tracking and observability, for rate limiting, etc. Then we have full observability and monitoring with MLflow. We have covered that part already, but it came really handy for managing the bullet points I had in the Google Sheet. It made governance of agents really fast. Okay, so what changed with Lumio? Ollie, would you like to take over?
All right, thanks, Pragati. So to wrap things up with the Lumio case, let's visit and look at the concrete impact that we had. Basically, this is the after picture, what actually changed after the solution went into production. So Antonio still wakes up early in the morning and still has the same emails waiting, but basically the response time went from 4 hours to 45 seconds, and the emails that get resolved within the same day are almost 100%, so 97%. So the key message is here that AI agents augment your team. They don't replace them. Basically, they remove the repetitive lookup work so people can focus what actually requires the human judgment. And here's the Antonio after the solution. All right, things to remember. Token prices, as you have heard, are going up, so it's important to count your tokens and build dashboards to monitor costs. You can also use something called GPA or DSPY, as Pragati mentioned, to optimize your prompt. Then on the cost side, it could be a good idea to shut down your model endpoints when they're not in use, especially in development, QA, and staging environments. Then you can version your prompts like code, track changes in prompt templates for usability, and then Databricks offers good tagging solutions to get better visibility on the different solutions that are causing the costs. For those who want to get started on working with AI agents on Databricks offers an AI agent fundamentals course. The link can be found in the doc section. It's a great starting point if you wanna try it out and you're new on building agents on Databricks. We have also published a couple of technical blog posts adding to some of the topics today. Mohammed has written about the Solida benchmark for Databricks, how Genie turns Databricks Genie space curation in the benchmark-driven workflow. And Pragati here, as mentioned, has written a complete guide on deploying LangGraph workflows to Databricks. Those links can be also found in the docs. or from Solido website. All right, so the key takeaways to wrap up. Production is the real challenge. As said in the beginning, 95% of the AI agent POCs never make it, so you should start planning from production from day one, and hopefully today you get some of the tips how to do that. Data quality matters more than the actual model selection. Governance is not an afterthought. You should build secure, compliant, and add guardrails in the pipeline from the beginning. Automating the full life cycle using CI/CD pipelines to ensure that every change goes through evaluation and deployment consistently across all the different environments. Then evaluate relentlessly your solutions, things like retrieval quality, correctness, and knowing when the agent doesn't know something are all measurable. And finally, the results for our case speak for themselves. Lumio went from 4-hour response time to 45 seconds. All right, here was all the content we had. Let's check the questions and answers. Did you, Pragati, already pick something you want to take first?
Yes, we have a lot of questions in Q&A. Let's try to cover as many as we can. But thank you, everybody, for your questions. Let's cover them. Also, before I start, when I'm going to share this presentation with you, there are a lot of extra things in the appendix section. For example, using Lakebase for the memory, or using AI SQL. So some topics that might come handy in your organization. So just have a look. Okay, let's go with, what do you mean when the new manual data is incorrect? Okay, that means, for example, in our Lumio use case, Lumio wants spare part information on motor ABC 1, 2, 3, 4, 5. Usually what companies do, they keep these manuals updated. For example, this manual has been decommissioned, it's not going to be used, this spare part, etc., etc. So Antonio needs to have that manual updated, or the answer agent is responding to should always refer to the new manual instead of the previous one. That means the data agent is fetching should be updated, not just the manuals, but also the SQL queries. So that means the data is not incorrect, but the data is old. That's what I mean, that the agent should always track the new data. I hope that I answered your question. Yes, in my company, we are having APIM as gateway. Yes, I think somebody else also asked about third-party gateway. Databricks supports that. I have heard Kong as one API gateway, which you can use. But yes, it's fully flexible. You can have your own AI gateway and redirect the request. We have also done it with Lumio. So it's totally possible. In Lumio project, there is an integration between Outlook and Databricks agents. No, the reason we didn't have an automated access is because we still want human in the loop. Antonio, our guy, has been handling very critical questions, and we do not want agents to have everything automated. We still want Antonio to have one final glance before answering. That's why we could have done automated workflows, but we don't want to, because the idea is not to replace Antonio. The idea is to help Antonio. Could you use Databricks as layer tool for agentic enterprise automation, such as automated tasks within SAP, S4HANA, or other ERP? I actually don't have enough information on integration with S4HANA or other ERPs. But I recently read this article on Databricks that they are building a lot of, they have a very tight integration with SAP, and maybe that is something you can read about. But yeah, Databricks is very integrated nowadays with SAP,
Yeah, and
fetching.
I think Databricks supports a lot of like external MCPs. So if the tools that you want to automate or the systems you want to deploy agents, it could be that they already have an MCP connection that the agents in Databricks could use. So that's maybe one option.
Yeah. So another question is, what about using framework like LangFuse from management and tracing instead of an MLflow? Yeah, they are just other tools. We are promoting, not promoting, but we are talking about MLflow is because you don't have to do anything. It is there. You use Databricks services. That means everything is integrated with MLflow. If you want to use other framework, please go ahead and let me know how your experience is, or just compare the performance of MLflow. If LangFuse is better, do let me know. I won't mind switching it to LangFuse. Third-party API, AI gateway. I think we have talked about it already. Do you similar approaches for other pillars beside AI governance? Especially, I am interested in pillar number one, AI organization. Thank you so much, Wilhelm, for this question. And the purpose, I really wanted to talk about governance in this webinar for exactly the same reason, that know what profile you are and address your pillar accordingly. There's a lot of content on Databricks website. I think I added a lot of links in the presentation for 5 pillars. If I haven't, I will look one more time and add appropriate measures to take for 5 pillars. If you are a person who is going to handle the number 1 pillar, there is a content available for that. But yeah, I will go through the presentation one more time, and if there aren't links addressing to other pillars, I will edit that. But yeah, there's a lot of content, and I will try to make some cheat sheet for other pillars. Do you have a presentation in grayscale for people with color blindness? I think Nina has answered that question already. When and why would you choose Databricks as your platform instead of, for example, running the orchestration in Azure, Kubernetes, models in Foundry, etc.? Okay, it's it's a two-part question. First, why Databricks? I am a person who, I don't know, I don't have enough experience on AWS and Google, but I have worked a lot with Azure Foundry in specific. What I realized in Foundry is that a lot of services are not mature, and a lot of services are disintegrated. For example, if you want to have pipelines, I think they call it uh, like Databricks call it Databricks jobs. There's a concept of jobs in Azure as well, but then you have to go to another platform. For example, if you want to run ML pipelines, then you have to go to ML Studio. Then for some pipelines, when your data is one lake, then you have to go to Fabric, I guess. So it it's quite nice as a service, but I feel like it's so integrated, it becomes a bit difficult to configure all these services together. And especially when it comes to governance, it involves a lot of configurations. For example, if you're a developer, just one developer working on a problem, it gets a bit too much to manage these platforms. Um, Instead, you can just focus on the development on Databricks. I'm not criticizing Foundry, they have a different stack, but it just I was one developer for Lumio. So Databricks gave me the flexibility and it saved a lot of time. And when it comes to orchestration in Azure Kubernetes, if you want to save time and not time, if you want to save cost, orchestration in Kubernetes is the best solution to go ahead. Even in Lumio's use case, we are happy with the production, but in future, if we are scaling it to, let's say, 15 different countries, then orchestration is the fastest, it's the cheapest way to go ahead. So that depends on the scale of your problem.
Yeah, and I guess if you're already have a lot of stuff on Kubernetes and want to deploy models as a Docker containers or something and already have the know-how to use it, then I think it's fine. Databricks, on the other hand, if your lake house is on Databricks and then like using the ML and agentic solutions there is like the natural choice in a sense. And also the infrastructure management on Databricks is pretty light in a sense that you need to do the initial setup, but then it's much lighter after that.
Yeah. There's another question. Can you tell me about the most common use case? I'm not sure if I got the answer. Arvind, if you would like to clarify, would be nice. How is the processing time latency? That's a really good question, Toa. We were quite positively surprised with the processing time. Processing time also depends on how complex the question is. For example, if the question required our AI agent to use, let's say, 5 tools to come up with the answer, of course, the processing time increased. So if it's a simple question, it was fast. If it's a very complicated question, it was a bit long. But overall, we were not we also people, the business people at the Lumio side, they were quite happy with the processing time. Daily volume of the data to go through this pipeline. Again, I think I don't get this question.
It refers to the declarative pipeline slide.
No, we were not running the pipeline daily. We were running the pipeline every time there was a change. So it was triggered on basis of the change instead of having it run daily. But that if for your use case you think daily volume is enough, go ahead. Like there are so many ways to trigger your pipeline. It could be continuous, it could be triggered, it could be scheduled. So you see what is fit for your use case. How the PI data is cleaned across all layers and how frequently? Yes, that's a really good question. Thank you, Romans, for asking that question. The PII data, we used a lot of row-based and column-based masking. There are other Databricks services that you can use to have masking based on your permissions. Another thing we used was ABAC policies to clean the data. On top of that, on top of everything, on top of the data preparation, we also used guardrails that there are OpenAI provided guardrails that every time we were asking a question, the question used to go to the guardrail. The guardrail decides if this answer is question, if I should answer this question or not. Only when the guardrail thinks it's a safe question, then it answers the question. And the output also goes through the guardrail. So that is one way you can do that. Another thing is there are inbuilt guardrails in API gateway. That is one reason. I don't know about other API gateways, but at least Databricks provide inbuilt masking, reduction, and filtering of the harmful content in the API gateway.
Maybe I can add to that. There was a question about time travel. So if you use row filters or column masking in tables, time travel is automatically disabled for those tables. And Databricks offers for the detection of the PII data, there's something called automatic classification, which you can turn on. And then if that looks something that could be useful for you, you can automatically tag the tables and columns based on that and use the ABAC policies for access management, as Pragati mentioned.
Yeah, thank you, Ollie, for covering the part I totally missed. Maybe an off-topic question: is the data handled the same way when using OpenAI SDK as when using Genie? And does any data leave EU? Okay, I'm gonna answer this part first. If the data leaves EU, at least what I have seen on the Databricks website, I don't know what happens behind the scene, but this is what they claim, that they do not send any data to models. Databricks retain the data for 30 days or so, but they are not, that's only for some legal purposes, but the data doesn't go to the models. That's what they say. Being, for example, being sent to a provider in US. Databricks claim that this is not happening, but I don't know. I don't know if to trust this claim or not. I think we can, but yeah, I cannot really comment on that. Is the data handled the same way when using OpenAI SDK as when using Genie? Uh, I'm not really sure how to answer this question.
I think Genie behind the scenes uses Claude
Yeah.
models. They haven't like officially published that, but that's at least my understanding.
Mm-hmm.
But not sure how that compares to OpenAI SDK.
Yeah, Genie is their native. If people who don't know, Genie is the native Databricks assistant, which is free to use, and it's just the way it handles it. It captures the semantic information about your tables and answers your questions in human interpretable language. What are the chunking strategies? I think I covered this already during the presentation. How was the quality of parsing 6,000 documents? This is also something I covered. Try testing AI parse document library provided by Databricks. It's quite nice. Any best practices to combine your agent framework with NVIDIA NeMo Claw? I don't have experience with NVIDIA NeMo Claw. Um, I have I have seen a lot of developers within Solita working on NVIDIA, but I cannot answer that question right now. Maybe I can send you a email or something once I have, if there's somebody within Solita who has combined NVIDIA with Databricks. Uh, when updates introduce error, what happens?
Yeah, I think this came regarding the slide about the declarative pipeline update. So if that fails, what happens?
Rollbacks. It just goes to the previous stable version. So the agent is always running. It could be just it's running on the previous version, just healthy rollback strategies. Uh, does the wrapping process also support Java related frameworks like Spring AI? I think so. I think so. That's what Databricks also tell that you can make any agent compatible with Databricks. I have to check the documentation if it supports Java related frameworks, but I know Python. Um, Sorry, I have to check about this if it's compatible with Java. Yes, I know it's compatible with C languages. Not sure about Java. Um, After wrapping, can we further develop the internal agent solution? Yes, yes, you can. You just make you are just putting a wrapper around it so Databricks can access your agent. But whatever happens inside, it's code. Feel free to change whatever you want to. Are tools a part of MCP? That's a really good question. I think people get often confused MCP and tools. Consider MCP as a type of tool. Tool is sort of an umbrella term, which is like a capabilities you give to agent. And MCP is a type of tool which gives your agent access to external data. So MCP is a tool, but it's a different type of tool.
Yeah, I would say MCP is just a fancy way of saying integration.
Yeah. Can we automate context update if the goal was not achieved? I'm not sure, Ollie, if I got the question. Can you, if you got the question?
Not sure.
Yeah. Okay.
Maybe this is related to RAGs and vector searches. So, well, Peter, if you're still there, maybe you can elaborate a bit more.
Yeah. Okay. We are quite on time. It's 11:29.
Yeah,
We
there
are.
was one more. Can we see how many DPUs my code burned?
Yes, that's a really good question. I'm sorry if I forgot to put that. So for all the AI related application, um, Databricks charge you 7 cents per DBU. Now, what is a DBU? It's Databricks unit. To convert, it's a unit that is associated with the pricing. For example, recently I was checking because the token price has increased. I was seeing I'm using Sonnet 4.6. So it says Sonnet 4.6 burns 42 DBUs per 1 million token. So everything you see about the agent, about the tokens, everything is specified in DBUs. Just refer to the database documentation for the updated cost and just multiply the price of DBU with the number specified there, and you will get your perfect answer. I hope I answered that question. But I guess it's time to say goodbye to you all. You can reach out to me or Ollie on LinkedIn if you have any questions. I hope you learned something today.
Thank you from my side as well, and have a nice day.
Thank you so much. Bye.